this.
Okay, so first we take the first derivative of this function.
And that equals 3x squared
Hmm.
minus 6x.
Okay, and then
And then we would set 3x squared minus 6x equal to 0.
we set it equal to 0. And why are we setting it equal to 0?
To find the critical points.
Mm. Okay. And what are the critical points?
They're wherever the original function has local or absolute extrema.
Local or absolute minima, uh, extrema, or they are also the points at which the derivative does not exist.
Yeah.
Okay, so we set it equal to 0 to find out the critical points, and then
And then we would solve it. So that's,
okay, let's solve it. This is a quadratic expression.
yeah. So x equals 2.
X equals to 2.
Mm-hmm.
It will have only one critical point.
This is one of the places I'm not entirely sure on. I think there's also x equals 0.
Yes, so first of all, if this is a quadratic equation, right, you can see this is a quadratic equation. A quadratic equation will have two critical points
Okay.
because a quadratic equation has two solutions, but not always. Sometimes it can have imaginary solutions as well. But in this case, so how do you solve this? How did you solve this, Nandana?
I factored out 3x.
Yeah, you factored out 3x, so you get
X
x
minus
minus
2.
2. Right now you have to use the zero product property. You have two factors. This is one factor and this is another factor.
Yeah.
You know the zero product property, right?
Is that where you just divide it from 0?
Zero
Or
product,
divide it from 0?
no. Zero product property is if the product of two numbers is equal to 0, then either the first number will be equal to 0 or the second number will be equal to 0.
Okay.
So when we solve quadratic equations, especially we use this property to solve quadratic equations. Now you know there are two factors. This is first factor 3x, this is another factor x minus 2. The product of these two factors is equal to 0. So either 3x will be equal to 0 or x minus 2 will be equal to 0.
Okay.
Right? So from the first equation we get x is equal to 0, and from the second equation we get x is equal to 2. Okay,
Mm.
so we have the two critical points, and what do we do next?
I've been taught to do the sign analysis.
The sign analysis or the sign graph, exactly. So we will draw a number line, sort of a number line, and we will plot the critical points. 0, 2. Now we have to find out that these two critical points have divided the number line in three intervals, right? First interval, second interval, third interval. So we need to find out that in which interval the first derivative of the function will be positive and in which
Mm-hmm.
interval will be negative.
Mm-hmm.
Okay, so
Uh, so I would sub in values in between and before and after the critical points.
yes, you can take any value. So if you're testing this interval and
Mm-hmm.
it goes all the way to the negative infinity, and here it goes all the way to the positive infinity. Now you can
Yeah.
take any value. If you want to test the last interval, take any value, Nandana, greater than any number greater than 2.
Mm-hmm. So 3?
3, and plug in 3 in this equation.
Yeah. So it's 9.
So it's 9. So we don't have to completely solve it. We just have to check whether this expression will be positive or negative.
Right.
So it's 9 is positive. So for
Mhm.
any number in this interval, this expression will be positive. Now just quickly check for the other two intervals.
So from negative infinity to 0, it's positive, and 0 to 2, it's negative.
Okay, perfect. So these are the signs of the first derivative
Hmm.
of f prime x. Okay,
Yeah.
so this means what? This means that my function now, Nandana, if the first derivative is positive before 0 and it is negative after 0, right? So what can
Hmm.
you tell me about the point 0? Is it a local minima, local maxima?
It's a max.
It's a maxima. So the shape of the graph will look like this,
Right.
right? And then
Hmm.
what about 2?
That's a minimum.
That's a minima, so the shape of the graph will kind of look like this.
Yeah.
So that means 2 is a point of local minima and 0 is local maxima. So I think you're good with this. You said you're not great with this concept.
It's just the problems where I have to sketch the graph. So some of them are a little more complicated than this. So just those ones.
Okay, we'll also sketch this curve. Okay, we'll sketch this curve as well. Okay, so we have found out the critical points, the points of um, local maxima, local minima. Now let's just quickly write the intervals. Okay, so the function will be increasing. It will be increasing in the intervals. Can you tell me the interval?
Negative infinity to 0 and 2 to positive infinity.
Okay, and it will be decreasing.
It's decreasing on 0 to 2.
0 to 2. Okay, perfect. Now we have to find out the inflection points.
Hmm.
Okay, so how do we find out what is an inflection point?
So an inflection point is where the function changes concavity.
Okay, and how do we find out that?
Finding the second derivative and then setting it equal to 0.
Okay, okay, let's find out the inflection point. Let's find out the double derivative, second derivative.
Uh-huh.
This was the first derivative, 3x squared minus 6x.
Yep. So the second derivative is 6x minus 6.
6x minus 6, okay. You put it equal to 0.
Hmm. So x equals 1.
X equals 1, okay. Again, we'll do the sign analysis,
Yeah.
okay. Then identify the intervals.
Hmm. Okay. So f is concave down
Mhm.
on negative infinity to 1
Okay, so here it will
and
be concave
concave
down
up. Yeah.
and here it will be concave up. Okay,
Mhm.
okay. So
On 1 to infinity. Okay.
yes, from 1 to infinity it will be concave up. And that's it. That's all the information that you need in order to sketch the graph of this function. Okay, now let's come to
Okay.
the sketching part. You know the shape of concave up and concave down, right?
Yes.
Okay, so this is your concave up will be like this, and concave down will be like this.
Hmm. Oh, you're breaking again.
Hello, Nandana, can you hear me?
Yes, it's better now, but it's still not good.
Okay, okay. Okay, Nandana, now I'm gonna draw a number line,
Okay.
okay? And I'm gonna plot all the points, the critical points and inflection point, okay? Then you tell me the
Mhm.
shape of the graph. Try to identify the shape of the graph. How will it go from which point to which point, okay?
Mhm.
0, 1, 2. So we have the critical points are 0 and 2, and the inflection point is 1, okay?
Yeah.
Okay. Now, what do we do next? How do we actually sketch the graph?
Mm, so 0 is a max
0 is a
and
max.
f concave down,
Hmm.
1.
Yeah,
So it's gonna form like a upside down U over 0 and go down until 1.
yeah. So so the graph is coming from negative infinity. We have to identify its nature all the way from negative infinity. We'll start sketching it from negative infinity. Now we see that from negative infinity to 0, it is increasing, okay?
Mhm.
So it will be coming somewhere from here. We don't know it's
Mhm.
0 right now, like where exactly it will cross the x-axis. We have not found out the 0. Ideally, we should
Yeah.
also find out the 0 of the graph so that we know that where exactly it will touch the x-axis. But it's okay. We are just sketching its rough graph. So we know that from negative infinity, it is increasing all the way up to 0. Okay. And its
Mhm.
shape is concave down. So it will be kind of like this all the way up to 1. So I'm going to start
Yeah.
it from here. Let me change the color. Okay. So it is coming all the way up from negative infinity. And at 0, from 0, it will change its behavior from increasing to decreasing.
Mhm.
Okay. So it will start decreasing, but its shape will be still concave down all the
Right.
way up to 1. And then from 1, its shape will change to concave up, but it will be still decreasing all the way up to 2. Let's change its shape. We have to change its shape, but it is decreasing, decreasing, decreasing. And at 2, we have a minima. So that means from 2, it will start increasing.
Mhm.
Okay. And yes, and from 1, its shape has become concave up. And that's it.